Somewhere in the outer solar system on Valentine's Day of 1990, a spacecraft that had already done everything anyone had ever asked of it was given one final assignment before its cameras were switched off forever. It was told to turn around. Not toward Jupiter, not toward Saturn, not toward anything it had been sent to study. It was told to look back at the tiny, distant, nearly invisible place it had come from and take one last picture before the instrument responsible for it went dark for good. What came back months later after painstakingly slow transmission across billions of miles of space wasn't a dramatic photograph. It didn't show storms or rings or moons. It showed almost nothing at all, a single pale point of light, less than a pixel wide, caught inside a stray beam of scattered sunlight, sitting in an otherwise empty frame of black. And when the scientist who fought hardest to get that picture taken finally described what it actually meant, people who had spent their careers studying the universe went quiet. This is the story of the last photographs Voyager 1 ever took, why they were nearly never taken at all, and why one image in particular, showing almost nothing, ended up saying more about our place in the universe than nearly anything else humanity has ever photographed. To understand why this moment mattered so much, you first have to understand what Voyager 1 had already accomplished by the time this idea was even proposed, and how close it came to never happening. Voyager 1 launched on September 5th, 1977 from Kennedy Space Center in Florida on a mission built around two flybys, Jupiter, then Saturn. It carried a suite of cameras and instruments designed to photograph those planets and their moons in more detail than anyone on Earth had ever seen. It reached Jupiter in March of 1979, sending back the first close, detailed images of the planet's swirling storms and its four largest moons, discovering active volcanoes on Io in the process, the first time anyone had ever observed volcanic activity on a world beyond Earth. It reached Saturn in November of 1980, capturing extraordinary images of the planet's rings and its hazy orange moon Titan. By the time it finished with Saturn, Voyager 1 had completed its primary mission, and its cameras had done exactly what they were built to do. After the Saturn flyby, mission planners made a deliberate choice that would define everything that came after. Rather than sending Voyager 1 onward through the plane of the solar system toward the other outer planets, the way its twin, Voyager 2, would go on to visit Uranus and Neptune, they used a close pass by Saturn's largest moon, Titan, to bend Voyager 1's trajectory sharply upward, out of the plane where all the planets orbit, and send it climbing away from the solar system entirely. It was a trade-off. Voyager 1 gave up any chance of visiting another planet in exchange for a closer look at Titan's thick, hazy atmosphere, which scientists suspected, correctly, might hold clues about the kind of chemistry that existed on early Earth. From that point on, Voyager 1's course was set. It was leaving, and it wasn't coming back. For nearly a decade after that, Voyager 1's cameras had nothing left to photograph. There were no more planets in its path. It kept transmitting data from its other instruments, magnetic field readings, particle counts. The ordinary long-distance housekeeping of a spacecraft headed steadily outward. But the imaging system, the cameras that had produced some of the most breathtaking planetary photographs in the history of astronomy, sat mostly idle. And by the late 1980s, NASA was preparing to shut that imaging system down for good. Keeping the cameras powered and calibrated cost, energy, and communication bandwidth that the mission team increasingly needed for other instruments, ones that would keep collecting meaningful scientific data long after there was nothing left to photograph. The plan was straightforward. Once Voyager 1 finished its work at Saturn's system and moved on, the cameras would be turned off permanently, freeing up power and simplifying operations for the long journey that lay ahead. That's where Carl Sagan enters the story, and where the idea for one final photograph very nearly didn't happen. Sagan, the astronomer, author, and science communicator, who had already become one of the most recognizable public voices in American science, had been pushing for years for the Voyager team to consider something unconventional. Before the cameras were shut off for good, turn them around. Point them back toward the inner solar system, back toward the small, rocky planets Voyager 1 had left behind more than a decade earlier, and take one final photograph. Not because it would reveal any new scientific data of significance, but because of what it would show us about ourselves. Sagan had first proposed the idea years earlier, and for a long time it went nowhere. There were real, practical objections. Pointing the camera back toward the inner solar system meant pointing it dangerously close to the sun itself, and Voyager 1's imaging system, like most spacecraft cameras of that era, wasn't designed to handle direct sunlight in its field of view without risking damage to the delicate optics inside. Mission engineers were understandably cautious about the idea. There was no scientific requirement driving it, and there was a real, if small, risk to the equipment. Sagan kept advocating anyway, and eventually, with the imaging system's permanent shutdown already scheduled, mission managers agreed to let the team attempt it, carefully, as one of the very last things Voyager 1's cameras would ever do. The command sequence was worked out by the imaging team, with Candace Hansen among the scientists responsible for planning the exact sequence of exposures. On February 14th, 1990, Voyager 1, then roughly 3. 7 billion miles from the Sun, farther out than Pluto's average orbit, executed a series of commands that turned its camera platform back toward the inner solar system and captured a sequence of 60 images, an attempt to photograph as many of the solar system's planets as possible in a single coordinated sweep, a project that would later become known as the Solar System Family Portrait. The images didn't come back all at once. Voyager 1's transmission rate at that distance was extraordinarily slow by any modern standard, and it took months for the full set of images to make their way back to Earth, arriving gradually through the spring of 1990 as the spacecraft's limited communication bandwidth allowed. When the full sequence was finally assembled, it showed 6 of the solar system's planets, each captured as it appeared from Voyager 1's extraordinary vantage point far above and beyond the plane where all the planets orbit. Mercury proved impossible to capture, lost in the glare of the Sun it orbits so closely. Mars, at the time, happened to be positioned in a way that made it too faint and too close to the Sun's scattered light to produce a usable image. Pluto was simply too small, too dark, and too far from Voyager 1's position to register at all. But Venus, Earth, Jupiter, Saturn, Uranus, and Neptune all appeared in the completed portrait. Each one nothing more than a tiny point of light or a barely resolved disk scattered across a mosaic of dark frames. The first, and to this day the only, photograph ever taken showing our solar system's planets together from outside their own orbital plane. One frame in that sequence mattered more than any other, and it's the one this story is really about. In the frame containing Earth, captured from a distance of about 7 billion miles, our entire planet appears as a single point of light less than a pixel across, a fraction of the image, caught almost by accident inside a band of scattered sunlight that streaked diagonally through the frame, an optical artifact caused by sunlight bouncing internally within the camera's own optics as it pointed uncomfortably close to the Sun. Earth sits inside that stray beam of light, not because of anything meaningful about its position, but because of ordinary lens physics, a coincidence of geometry that gave the image an unintentional, almost poetic quality. Our planet caught inside a shaft of light suspended in an otherwise empty black frame. Sagan didn't just push for the photograph to be taken. He understood, before almost anyone else, exactly what it would mean once people actually saw it. In 1994, he gave a commencement address at Cornell University where he described what that image represented, and the language he used that day became some of the most quoted words in the history of popular science writing. He described Earth in that photograph as a mote of dust suspended in a sunbeam, and pointed out that every human being who had ever lived, every war ever fought, every king and peasant, every scientist and every artist, had lived out their entire existence on that single point of light. He later expanded those reflections into a book, Pale Blue Dot, published in 1994, built around the idea that our planet, for all its wars and borders and grand ambitions, occupies a genuinely tiny, genuinely fragile position in an unimaginably large universe, and that the photograph itself was, in his words, a demonstration of the folly of human conceits. It's worth being precise about why that image had the effect it did, because it wasn't really about the photograph's visual content at all. There was almost nothing to see. No continents, no oceans, no clouds, nothing recognizable as a planet in any conventional sense. What made it powerful was entirely conceptual. The deliberate, almost startling contrast between everything human civilization has ever considered significant, every historical event, every personal triumph and tragedy, every border drawn and redrawn across the surface of this planet, and the sheer physical insignificance of that same planet when viewed from far enough away that it no longer even resolves into a disk. Sagan wasn't arguing that human life or human history don't matter. He was making the opposite point in a way, that everything we have, everything we are, exists entirely on that one small pale dot, and that recognizing how small and how alone it appears from a distance should make us more careful with it, not less invested in it. That idea landed with an intensity that surprised even the scientists involved. The pale blue dot photograph has gone on to become one of the most widely reproduced and referenced images in the history of space exploration, appearing in textbooks, documentaries, museum exhibits, and countless discussions of humanity's place in the cosmos, not because of any scientific data it contains, but because of what it represents. It's a rare case in the history of astronomy where an image with essentially no scientific value in the conventional sense became one of the most philosophically significant photographs ever taken. Shortly after the family portrait sequence was completed, exactly as planned, Voyager 1's imaging system was permanently powered down. There was no dramatic failure, no malfunction, no slow decline. The cameras simply completed their final assignment and were shut off deliberately to conserve power and communication bandwidth for the instruments that would carry the mission forward through the following decades. The magnetometer, the plasma wave detector, the particle counters, the instruments that, years later, would go on to confirm Voyager 1's crossing of the heliopause in 2012 and detect the strange, persistent plasma emissions in interstellar space that scientists are still working to fully explain today. Voyager 1 has not taken a photograph since February of 1990. Every image the spacecraft has ever produced was captured before that date. In that sense, the family portrait and the pale blue dot image aren't just significant photographs from partway through the mission. They are, quite literally, Voyager 1's final images, the last things its cameras ever saw before that entire system went silent for the remaining decades of the spacecraft's operational life. There's something worth sitting with in that fact alone. A spacecraft that spent its first 13 years capturing some of the most detailed and consequential images ever taken of Jupiter, Saturn, and their moons, chose, for its very last act as a camera, not to look outward at some new, undiscovered world, but to look backward at the place it had come from. That choice wasn't Voyager 1's, of course. It was Sagan's and the mission team's, made deliberately and with real institutional resistance, right at the edge of the window when it was still possible to make it happen at all. If the imaging system had been shut down even a few weeks earlier, on the original, more conservative timeline mission planners had been considering, the pale blue dot photograph would never have existed. There would be no image of Earth from beyond the orbit of Neptune. There would be no commencement speech built around a mote of dust in a sunbeam. There would be no framing at all of what it actually looks like to view our entire civilization from a vantage point so distant that our planet ceases to be a place and it becomes, instead, a single point of light indistinguishable from noise. It's also worth being honest about the technical achievement involved in capturing that image at all, because it's easy to treat the pale blue dot as a simple snapshot when it was, in reality, an extraordinary feat of precision engineering, operating at the very edge of what was possible with 1970s spacecraft technology. Voyager 1's cameras had to be pointed with extreme accuracy toward a target, Earth, that was, from that distance, not just small but essentially indistinguishable from any of the thousands of background stars filling the same general region of sky. The spacecraft's onboard computer, built with a fraction of the processing power of a modern pocket calculator, had to execute a precisely timed sequence of camera movements and exposures, all based on commands sent from Earth more than 5 hours earlier, accounting for a spacecraft moving at tens of thousands of miles per hour, all while carefully avoiding pointing the delicate optics directly at the sun long enough to cause damage. Getting a recognizable pixel of light in exactly the right position, inside a single frame, out of 60 total images spanning 6 different planets, was not a simple point-and-shoot operation. It was closer to threading a needle from a distance of nearly 4 billion miles, using equipment that had already been operating for 13 years longer than it was originally designed to last. The other planets captured in that same sequence deserve their own mention, if only because they help put Earth's portrait in context. Venus, Jupiter, Saturn, Uranus, and Neptune all appear in the mosaic as similarly tiny points or barely resolved disks, each one reduced to the same kind of visual insignificance that Earth experiences in its own frame. Jupiter, a planet more than 1,000 times the volume of Earth, appears as scarcely more than a bright dot. Saturn, with its famous rings spanning a distance wider than the gap between the Earth and the Moon, is barely distinguishable as anything more than a faint point of light lost among the stars. Seeing all of them together, reduced to that same scale, reinforces the exact point Sagan was making about Earth specifically. Distance erases scale entirely. From far enough away, the difference between a rocky planet the size of Earth and a gas giant 1,000 times larger simply disappears. What remains is only a scattering of small points of light, none of them obviously more significant than any other, adrift in the same vast darkness. There's a quieter piece of the story that rarely gets told alongside the more famous parts, and it involves Voyager 1's twin. Around the same period, mission planners considered attempting a similar family portrait sequence using Voyager 2 as well, from its own position in the outer solar system. In practice, technical and scheduling constraints meant Voyager 2 never completed anything comparable to Voyager 1's full 60-image sequence, and the family portrait, as it's remembered today, in the pale blue dot specifically, belongs entirely to Voyager 1. It remains the only spacecraft in history to have captured that particular kind of outward-looking, backward-glancing view of the solar system as a whole, taken from a position so far beyond the planets that all of them, together, could fit within a series of single camera frames. In the decades since, the pale blue dot photograph has taken on a life well beyond its origins as a single command sequence executed by an aging spacecraft on Valentine's Day in 1990. It's been referenced in NASA mission planning documents, cited by scientists and engineers working on later spacecraft as a kind of philosophical touchstone for why exploration matters, and returned to again and again in public discussions about climate change, nuclear risk, and the broader question of how a species with the capacity to see itself from 4 billion miles away chooses to treat the only home it actually has. It has appeared on the covers of books that have nothing directly to do with space exploration, used as shorthand for perspective itself. The idea that most of what divides us, most of what feels urgent and enormous from inside our own daily lives, looks considerably smaller and considerably more connected from far enough away. None of that emotional and cultural weight required any additional scientific discovery. It didn't need Voyager 1 to find something new. It needed Voyager 1 to stop looking outward, just once, at the very end of its imaging life, and look back. The scientific value of the pale blue dot photograph, in the traditional sense, is genuinely minimal. It contains no data about planetary composition, no measurements, nothing that advanced any specific research question. Its value lies entirely somewhere else in what it demonstrated was even possible, that a piece of 1970s engineering, running on computing power that would be considered primitive by nearly any modern standard, could be aimed with enough precision, from a distance of nearly 4 billion miles, to capture the entire visible history of human civilization contained within a single, nearly imperceptible point of light. Voyager 1's cameras have remained off ever since. They are not coming back on. Every other system on the spacecraft has continued to be carefully managed and, where necessary, shut down over the following decades as its power supply has slowly faded, but the decision to permanently retire the imaging system in 1990 was final. From the start, made deliberately, to prioritize the instruments capable of collecting data over the vastly larger stretch of the mission's ongoing scientific life. In the years since, those remaining instruments have gone on to make discoveries the Voyager team in 1990 couldn't have fully anticipated. The crossing of the heliopause in 2012, the detection of persistent, unexplained plasma emissions in interstellar space starting in 2017, magnetic field readings that have forced real revisions to how scientists understand the boundary between our solar system and the rest of the galaxy. All of that came after the cameras went dark. None of it involved a single new photograph, which is, in its own way, part of what makes the pale blue dot so unusual as a scientific artifact. It isn't a discovery in the conventional sense. It didn't reveal anything about the universe that wasn't already understood in some abstract mathematical way. Everyone already knew Earth was small compared to the vastness of space. Nobody needed a photograph to prove that mathematically. What the photograph did was something different, something closer to what art does than what data does. It made an abstract fact emotionally real, in a way that equations and distances measured in billions of miles never quite managed to achieve on their own. Scientists who had spent entire careers working with numbers describing the scale of the solar system found themselves affected by a single, nearly blank photograph in a way those numbers alone had never managed to produce. That's really the heart of why this particular set of images, out of everything Voyager 1 ever captured across Jupiter, Saturn, their rings, and their dozens of moons, remains the one most people still talk about decades later. Not because it was the most detailed, not because it was the most scientifically significant, because it was the last thing the spacecraft's eyes ever saw, and because what it chose to look at, in that final moment before going permanently dark, was us. Voyager 1 has continued traveling outward every day since, its remaining instruments still transmitting, its power supply still slowly fading year after year, closing in now on 50 years of continuous operation from a machine that was only ever built to last 5. It has no cameras left to see any of it. Whatever new discoveries it continues to send home come entirely from instruments that measure fields and particles and waves, invisible things translated into numbers rather than pictures. But somewhere in its onboard memory and somewhere in the archives at NASA, that final set of 60 images still exists, unchanged since 1990, showing 6 planets scattered like scraps of light across a mosaic of darkness. And one of them, a fraction of a single pixel wide, caught inside an accidental beam of scattered sunlight, holding, in Sagan's words, everyone who has ever lived. If you want to see how far this same aging spacecraft still has left to go and what its remaining instruments are still finding out there in the dark, that's a story worth following. Subscribe if you'd like to keep up with it.